Okay, let's look at this problem here. Try to calculate the integral here with cosine and tangent and from 0 to 2 pi. So this is actually requires some tricks and which are actually quite common here, like change of variables and leverage the symmetric property of functions and some other like trick, identities, along the way. All right, so let's get started. So how would you do that? You can pause the video and try to think about if you are able to solve this problem and then come back. All right, so one useful formula it turns out we have to use later on is for the second x. And for the guys who maybe not familiar with this is 1 over cosine x, right? So the indefinite integral is actually equal this one, logarithm with sec plus tangent, and you can refer to your calculus textbook for the background on this. All right, so let's get started. We'll try to solve the problem. So first of all, of course, you'll notice that this is a tangent here, which is sine over cosine. So you can rewrite this here, cosine x over 1 plus sine x over cosine x, right? And then, of course, you can further multiply cosine x on both numerator and denominator. You're going to get cosine square x on the top. And here, you're going to get cosine x plus sine x, right? And you try to do integral for this quantity, right? So let's do that. We rewrite it here, yeah. So how do we do this? All right. So you notice that there's some symmetric here, right? And this is 0 to 2 pi. So if you were to use a change of variable, let's say u equal pi over 2 minus x. So if you do that, what you're going to get is that du will equal negative dx, right? And you're going to notice that sine u is going to equal sine pi over 2 minus x is going to cosine x, and now similarly cosine u would equal sine x. All right, so if you do this change of variable, we can rewrite I in terms of u. Let's do that. So we have change of variables, we have this fact, and we have the other kind of facts here. So you're going to replace cosine with sine u here, right? And since this one, the range is going to be from pi over 2 to 0, and this is dx will be negative du. And here we can swap sine x and cosine x. It's going to be the same. Of course, when you do an integral, it is okay to, for example, to swap the range here by changing the sign here, right? So sign goes away because we swap the interval here. And then if from here to here, u and x, the same thing, right? Just you can just this variable is just a symbol here. We can say dx. But when you look at this, your original I, what you're trying to find, right? So we have it here. Originally, this is cosine on the top. This bottom is the same thing. So in other words, originally, I is equal to from 0 to pi over 2. And on the top, you have cosine square x. And then you have sine x plus cosine x and dx. All right. Here, by use change of variable, we just find out that it's actually equal to this one with sine square. Now, maybe this give you a hint because we know that sine square and cosine square, they add up to 1. So if you add up two integral here, right, and then what you get is 2i would equal to, in the numerator, you have the sine square plus 2 square. it becomes 1. Then it goes away, right? So let's do exactly that. We add up the two different forms of the integral, and what we get is that we know that this is equal to 1. So our integral right now is 1/2 of this quantity here, right? Now, how do we do that? This is sine and plus cosine. So it'll be easier if we have just sine one term, right? But this is again another common trick in the whenever you see sine x plus cosine x with some coefficient here. For example, this could be 3, could be 4. Sometimes you can do some multiplication so that it becomes sine x plus something here, some alpha, and then there's some coefficient here. Now here, because this is actually, the same coefficient here is 1 and 1, it turns out that we can use what is called a square root of 2 and do some multiplication here. So let's do that. So sine x plus cosine x, you can rewrite it as square root of 2 times 1 over square root of 2, right? Sine x plus 1 over square root of 2 cosine x. And here, of course, we don't want we don't want number. We want something like to use the trig identity here. So we know that sine pi over 4 equal cosine pi over 4. That's both equal to 1 over square root of 2. All right. So if you treat this as a cosine pi over 4, you treat this part as sine pi over 4, and then you're going to get square root of 2 sine x plus pi over 4, right? Because sine x cosine alpha and sine alpha cosine beta, that equals sine alpha plus beta. Here alpha is x, beta is pi over 4. All right. Now you're going to have this, right? So let's do that. Let's do the sine, and then this multiplication here, and then you know that this is equal to this one, right? And is also equal to, if you use, this is actually equivalent to this one, right? And then this would be equal to square root of cosine, right? So you just do the change of variable here, right? This becomes this one here, right? And then cosine negative x equal cosine x, right? So cosine, this one is equal x minus pi over 4, the same thing, right? Okay, it's because cosine alpha equal cosine negative alpha, all right? So here from these steps, you can just change a variable here, let this u, right? And then du equal dx, and then the range is going to be changed from negative pi to negative pi over 4 to positive pi over 4. Now here you notice that this function cosine is actually symmetric function. It's an even function, and this is happens to be even from, for even function, if a function that is even symmetrical here, no matter what that is, right? And then if you do the integral from a symmetrical interval here, from negative pi over 4 to pi over 4. Of course, I'm just drawing arbitrary function, right? 1 over cosine u would be different, right? But in this case, you can just double the interval from 0 to pi over 4. So it's equal to double of this integral here, but range is 0 to pi over 4. And this is the second, right? So, and here we use the formula here, in the range is going to be, pi over 4 and 0, and then when you plug in, you get this is the final answer. All right. So this again, this technique is quite common. Is when you look at this scary form initially, right, and then it turns out that you do some multiplication with change of variables and some other trig identities, and then eventually you simplify it to a very simple form, to an interval like this, which is very is easier for you to comprehend and to find the answer. All right, so that's it for this problem, and hope you enjoy it, and please subscribe to the channel and leave a comment if you have any other ideas about this particular problem. All right, thank you.